All right, before I go forward, I have my wonderful wife who's telling me, "Hey, we you trying to catch a speeding train? Slow that roll, bruh." She said, "Slow that roll, bruh." So I'm going to slow that roll. Heck no, I ain't got no time. But if you feel like I'm going a little too quickly explaining the stuff that's in the upcoming videos, take YouTube gives you the wonderful ability to slow down the video. You can slow it down 10%, 20%, slow it down to the point that you feel most comfortable. But some of you guys might think that my speed is a little too slow. You might want to speed it up. So speed it up 10%, 20%, 25%. And if you feel like you're not grasping information, you better slow that roll yourself. All right, let's go into page one. Remember the big picture? Yes, it's all about the money. Remember, this is business. Business, business, business. We're trying to get scholarship money. Oh, let me scroll to that page that we got to work on. I thought I had this set up. Here we go. Page 1 of 5. Can we smack that down? Let's do it. This first question, right? Take a look at the questions 12, 17, 11, 17. You're going to see a pattern with either the setup of the questions or the answer choice of the questions. Now, before I go forward, actually, if you pause the video, right? Pause the video. I'm going to scroll, right? I'm going to scroll. You can pause at any particular moment just to get a view of the questions because you might not have the hard copy in front of you. So I'm going to scroll one more time. All right, now you pause the video and then you can rewind. Let's pretend you already paused that video. What am I trying to explain here? I need you to get familiar with the answer choices and what they're showing you. All right, let's go. Before we do anything with these questions, I'm going to show you how easy it is to own these questions. Don't they look scary? Scary, yo. But here, I'm going to give you some basic information. All right, we already know about y. Whoops. Slip that down. Y equals mx plus b. That's all about slope-intercept formula. We know what the b is. Our b is going to be our y-intercept. That's when x equals 0. So algebra questions, they love dealing with slope-intercept formulas, but a lot of times you're testing theoretical concepts. That means, what does the b mean? What does the m mean? What's the m all about? The m is all about the slope. That is your rise over run, right? Or your slope. And then x is just a variable that they give us. It could be the number of cars, whatever it is. All right, y is also equal to f of x. Sometimes instead of showing you y, they'll show you f of x equals mx plus b. But what do we know y and f of x are? They're equal to each other. They're related to one another. So whenever you see f of x, you can substitute it for y. Now you know your basics is slope-intercept formula. So when x equals 0, right? When x equals 0, you have your y-intercept, which is your b. All right, now let's go into this page, data analysis, page 1 of 5. What are they talking about with those formulas that are given to us? Here, I'm going to give you a quick formula. All right, we know we got f of x. We know that that equals y. And let's say they came up with a formula equals, you know what? Let me give you an example with slope-intercept formula so we can compare page 1 of 5 to slope-intercept formula. So I'm going to put it equal to 200, right? That's our slope, x. Let's say x plus, and we have a y-intercept of 10,000. We cool? All right, next thing. If we were to say, if I had f equal f of 0, what is that going to equal? It's going to be y equals 200 times 0 plus 10,000. What is that going to equal? We know 200 times 0 is 0, 0 plus 10,000, it is going to equal 10,000. So our y equals 10,000. So if I created an x, y grid and I put 0 for x, what is our y value? It's going to be 10,000. All right, let's do f of 1. Now, we're still doing slope-intercept formula. 200 times 1, x equals 1 plus 10,000. These are the type of setups that you'll see in the SAT algebra portion of the exam. So what's 10,000 plus 200 is going to be 10,200. So when x equals 1, we get 10,200. What about x equals 2? Let me just put 2 here. I don't feel like erasing. So that's going to be y equals 200 times 2 plus 10,000. Okay, 200 times 2 is going to be 400. So our answer is going to be 10,400. So that is x equals 2, y equals 10,400. I know you're probably getting bored with this, but there's a whole point to this so that you can understand how to destroy the data analysis questions. 200, now I put f of 3, x equals 3, plus 10,000 equals 10,000. And what's 3 times 200? It's going to be 600. All right, so when x equals 3, we get an answer of 10,600. All right, now notice the absolute value difference from 0 to 1 is 1. The absolute value difference of 10,000 to 10,200 is a difference of 200. Same thing when we go 1 to 2 is a difference of 1. We go 10 200 to 10 400 is a difference of 200. And we do one more. 2 to 3 is 1, and then 400 600 is a difference of 200. You guys get it? It increases the same amount every time x goes up by 1, 200, 200, 200. So that is going to be a linear formula. So you could take a look at your XY t grid and find out if you're dealing with the um, um, linear model or exponential model. All right, so what does an exponential model look like? Here we go. We're going to take a similar concept, right? Well, we know our y-intercept for f of x was when x equals 0, we got 10,000, right? When x equals 0, we got an answer of 10,000. Now, for an exponential model, check out how this works. F of x equals y. Now I'm going to come up with a formula. Let's say it's 10,000. Exponential models always start off with the starting value. Doesn't end like slope intercept formula. At the end, we have b, which is 10,000. But for an exponential model, it's going to be 10,000 starts off the initial value, the starting value, and so on. All right. Now, what if I put down times, right, parenthesis, and I put down, let's do this, 100% plus 2% to the t power. Or let me put it to x. Usually they like to use t, but in this case we're using x because that's what our f of x is. But usually it'll be f of t, t meaning that you're dealing with time. All right, now we got the formula. So let's put some values in there. Let me do a quick t grid like we did last time with the slope intercept formula. Let's start off with 0. So f is 0. What is going to happen? That should be our y-intercept. So that'd be 10,000 times, what is 100% plus 2%? That'll be 100 and 2% to the x power. But we said our x power is going to be what? It's going to be 0. So what is anything to 0 power? Anything to 0 power is 1. So 1 times 10,000 is going to equal 10,000. So when x equals 0, our answer is going to be 10,000. Very similar to slope intercept formula. When x equals 0, we got y equals 10,000. All right, now let's do f of 1, and let's see what happens. Y equals the initial start value, the beginning value, 10,000, times. Now, instead of percent, I'm going to put it in decimal form. It still means the same. 100% plus 2% is also equal to 102%, but in decimal form, we move the decimal over 2 times, whoop, whoop, and therefore it's going to be 1.02. So now you see 1.02 means 102%, which also means 100% plus an increase of 2%. 100% of 10,000 plus an additional 2,000. Well, if it's due to first power, what is our answer going to be now? Our answer will be 10,200. So when x equals 1, we get 10,200. Now take a look at our slope intercept formula. It's the same thing. When x equals 1, we get 10,200. But here's where it's going to change. If I did f of 2, what is going to happen now? When this is exponential form, it's going to be 10,000 times 1.02, but to the second power. All right. So if we put that into our calculator, what's going to be our answer? Our answer will be 10,404. Notice it is different from when we put in 2 is x in slope intercept formula up here. Take a look up there. We got only 10,400. But down here, we have 10,404. So when x equals 2, we have 10,404, which is $4 more than x equals 2 in slope intercept formula, which is only 10,400. You guys see the difference? All right, let's do one more. F of 3. Y equals 10,000. Now we're going to go 1.02. Remember, that's 100% plus 2% to the third power. Use your calculator. What answer are you going to get? You're going to get $10,612.08. So when x equals 3, we get $10,612.08. See how much different it is from slope intercept formula with x equals 3, and we got 10,600. We got an extra $12.08 built in. That is exponential increase, ladies and gentlemen. So again, if I did the absolute value of 0, 1, it's 1. Absolute value of 1 and 2 is 1. 2 and 3 is 1. Now we go on to y values. What's the absolute value difference? It's 200, and it's increasing. So plus 200. What's the absolute value here? Oh, this is 204. What's the absolute value here? That's going to be 212.08. You see how it's different from what we had slope intercept formula? That's because in blue, what we had done here, this is exponential in formula. What we had before, it's linear. So don't forget that. I just gave you the basic information. Now, The key points. This is always going to be your starting value. So it's going to be labeled as quote unquote initial, the beginning value, or start. Also, it can be described as your, oh, what is that called? Coefficient. I don't feel like writing all that coefficient. So that's what the starting value is: initial, start, beginning, coefficient. Now, the value that's in the parenthesis, that's known as your factor, which is also known as your percentage, increase or decrease. I'm going to put slash increase or decrease. And then, of course, you have your exponent. And typically, instead of using x, sometimes they use x, but usually they use t for the exponent, which is usually related to time, which could be hours. It could be years, more than likely years. Sometimes it's minutes. You guys got that? If you know this, then you're going to destroy the first page. Now, I hate that it feels like it's stealing time, but hey, if you understand what I just talked about, then these questions become miraculously easy. So back when you paused to take a look at the questions, all right, you probably tried them, but waste of energy and time. I'm trying to cut that time for you. All right, let's try a question number 12, which is a medium level question. The model predicts that the population of Bergen was 15,000 in 2005. Now, right now, I'm trying to figure out this is a medium level question. I got to find out if 2005 is the very beginning or if it's somewhere in the middle or somewhere at the end. Now, it says here the model also predicts that each year for the next 5 years, for the next 5 years, that means 2005, it's the first year, the beginning year that they're using. Let me keep on reading and be a little patient. The population P increased by 4%. If it increased by 4%, take a look at your answer choices. First of all, we're looking for the starting value, 15,000. Where's that 15,000? The starting value should be there, or there, there, or there. Where do we not see 15,000 at the beginning? A and B are out, done. Now, what about the increase by 4%? If it's increasing by 4%, that would be 100% of the starting value plus 4%. If we combine those, that would equal 104%, which is also in decimal 1.04. And that's also known as our factor. Now, which answer is showing us a factor of 1.04? A is the answer, C does not work, and that's it, done. You guys get it? Let's try 17. Now they're being theoretical with this. Each year, the value of the investment increases by 0.49%. What does that mean? That means it's increasing 100% plus 0.49%. Now, if we were to add that up, that would be 100.49%. If we put it in decimal form, remember doing decimal, you get rid of the percent, you move the decimal over 2 times. So that means it's going to be a factor of 1.0049. So it's going up in value. Plus, they're telling you it is increasing. Now, if it is increasing, check out these words of its value the previous year, that means it is exponential. So far we know it is increasing. That's proof. Whoop. Now it's got to be exponential also. So I've got increasing and increasing. So therefore decreasing, decreasing. Good night. And which one is going to be exponential? Answer choice C. And we're in and out of the question. You good? Oh, but when would it be linear? When it's increasing by the same amount every year, not increasing a percentage of its value the previous year. Get familiar with those words. All right, let's do question number 11. The company opens an account with an initial balance, an initial beginning start balance of 36,100. We should see 36,100 there, 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 and there. Which two answers do not show it to us? Whoop, whoop. So C and B are out. It's got to be between A and D. I think you're catching on to this. Now we keep on reading. The account balance is given by an exponential function. Yep, each of those answers are exponential functions because they each show you t as an exponent. So we know that. Where A of t is the account balance in dollars, t years, and that is just describing what we already know, t years after the account opened. The account balance after 13 years is $68,071.93. Isn't that increasing from 36,100? Yes, it is increasing. So which answer is going to be the best answer? Could it be answer choice D? Look at the factor inside of that. You know what that 0.05 means? It's actually going down in value. Check this out. If I took 100% and I subtracted 5%, what am I going to have left over? I'll have 95%. So this is telling you that your 36,100 is going down by 95% every year, right? So if they told us that, that would be a parenthesis of 100% minus 95%, which is 5%. And 5% in decimal form is going to be what? That's going to be, get rid of the percent. Remember, get rid of the percent, move your decimal twice. That'll be 0.05. So that 0.05 means 100% minus 95%, which means that it's gone down 95%. So the only answer this can be increasing 5% because it went from 36,100 and increased to 68. The only answer can be A. That's 100% plus 5%, going up 5% every year for 13 years. Hoo, from when you first started. Question number 17. This is meant to be harder. Now, we got a T grid. They're shown as X, right? That's X, but they're also shown as Y. Remember, f of X, h of X, w of X, whatever it is always going to equal Y. Notice your X values. It is increasing by 2, absolute value of 2 each time. But the Y values, I'm trying to figure out if they're linear or exponential. What is the difference? It's going up in value, right? It's increasing by 31. Is that it? 0.31. And the next one, what is that increasing by? Call me out if I goof on this. 0.94 minus 5.4. I think that's going to be 0. 9 minus 5 is zero point 0.4. All right. Are they the same? Remember the example I gave you with linear formula? They're going up by the same amount. This one is going up 0.31, and the other one from 2 to 4 is going up 0.40. They're not the same. So therefore, it's not linear. It must be exponential. So that means it's going up in value. All right, let's go into the question. The table shows the exponential relationship between the number of years, that's your X, Hannah started training on the pole vault, and the estimated height, which is Y in meters, for her best pole vault that year. Which of the following functions best represents this relationship with X is equal to or less than 4? No problem, bruh. What is going to be your Y intercept? We're going to kill this, right? That XY grid over here is showing you your Y intercept. And that is, what's the Y intercept? When X equals 0. What is our Y intercept when X equals 0? 1.23. So that means at the very beginning, we had to start out with 1.23. Does that give us A? Is it in B or is it in C and D? Which two answers go in the toilet? Woo, woo. A and B. Now next, what about that percent, right? It's increasing in value. So which answer is showing us a factor that's increasing in value? The only one that's increasing in value by 12% every year is D. What happened to C? Side note, a lot of students get confused by this. What's happening within the parenthesis? If they were to ask you by what percent, because that's showing decrease, by what percent was the amount decreasing? Then we have to take our 100, we're going to subtract 12, and that's going to leave us with 88%. So it is a decrease of 88%. In other words, in our parentheses would be, 100% of last year's value of 1.23 is decreasing by 88%. If we subtract that, what do we have left over? We have 12%. Our 12% in decimal form will be 0.012. Oops, I goofed. That's 0.12. Thank you for calling it out, my subconscious. Bang. So that means it's going down in value. C is out. What's going up in value? It's going up in value over here because that represents 100% plus an increase of 12%. All right, question number 15. All right, let's analyze what they're showing. Now we see our answer choice. So I'm going to attack these answers from the bottom up whenever they're wordy. All right, what is the starting value? 5. What is our percent increase or decrease? That's going to be within here, the factor, right? When you see 1.0, 1.8, what does that mean? That means in parentheses, it would be 100% plus 80%. Let's prove it though. What is 100 plus 80? That'll be 180%. And what is that in decimal form? 1.8. Yes, it's a match made in heaven. So we're increasing by 80% with the exponent of t, starting off with $5, 5 shoe horses, 5 whatever it is. Shoe horses, what is that? Given the estimated number of employees at a restaurant where t is the number of years since the restaurant opened, which of the following is the best interpretation of the number 5 in context? The number 5 is the starting value. Is that answer choice D, the percent increase? No, it's not percent increase. It's the starting value. The percent increase is 80% for this guy. Answer choice C, the number of years the restaurant has been open. No, that would be T. What does the 5 represent? Is it B, the increase in the estimated number of employees every year? No, that would be 180%, right, of every year. So B is out. So A has to be our answer. Estimated numbers of employees when the restaurant first opened, the beginning, the starting value. You see how these questions aren't hard? Let's try this one. Question number 23. This is meant to be hard because it's in the 20s. All right, let's go. Let's go and get this. Take a look at your answer choices. You have your opening values, right? You're starting your beginning values. I'll bet money is more than likely between C and D because you guys should have seen a pattern in the previous answer choices. Then they're showing you factors. Your factors here, you got 14, which means that's 100% plus 1,300%. You guys get that? That's 100% plus 1,300% in that parenthesis. That's a factor of 14, 100% plus 1,300%. And then we have these guys, right? This one signifies a decrease. This one is an increase of 45%. And this one is a decrease of 45% over last year, 100% minus 45% will equal 55%. So it's going down in value. All right, let's read the rest of the question. For the function q, the value of q to the x or q of x decreases by 45%. Okay, it decreases by 45%. Let's take a look at our answer choices. I think the only answer it's going to be is C because 100% minus 55% is going to equal 45%, which is which is 0.45. Yeah, that's what it is. And in addition to that, they're telling us if q is 0 equals 14. So if x equals 0, what's going to be our starting value? It's got to be 14. It cannot be A, cannot be B. The starting value has to be 14. But D is showing us an increase. This is representing 100% plus 45%, which cannot be. It's got to be decreasing 45%. So therefore, C is our answer. Woo! Question number 22, meant to be hard. Two variables. Take a look at your answer choices. What's our starting values for each one? We got 4 on this side. We got 200 on this side. What's our factor? Our factor is what's in here. By the way, that 200, what does that represent? That is 100% plus, wait, yeah, 100% plus 2,000. No, 100% plus 1,900%. 100%, here, check it out. 100% plus 1,900%. If I add them up together, that'll be 2,000%. Oh, no, it's more than that. It's 19,000%. And then that'll be, gosh. Oh, gosh. Hold on. Oh, this is slick. These guys are mean. Sorry, I brought this up. Not that they'll ask you this, but what would that be in parentheses? It'd be 100% plus, oh, gosh, 19,900%. If I add those together, it would give me 20,000%. If I turn it to decimal, I got to move decimal over 1 to 2 times. So that's what you have in parentheses. Wow, that's huge. I don't think they'll ask that question, but just in case, now you know what that means. All right, so again, the initial start value is 4 or 200, and then we have our factors built into these parentheses. Let's go into the question. Two variables, x and y, are related such that for each increase of 1, so they're telling us when we increase x by 1, that would be your exponent. I'll do it in red. In the value of x, the y increases by, oh, shoot. Awesome. By a factor of 4. Oh, please. Which one is dealing with the factor? Remember the green? That's your factors. Which one is showing us 4? Not A, not B, not C. Yep, it's D. That's your factor 4. That question number 22, is Hazard, but it means most students answered the question incorrectly because they didn't know what they were looking for. In addition to that, just to save you, right? They said when x equals 0, y equals 200. When we see that, right? When x equals 0, that is your y-intercept. So if I did plug in 0 there, what's 4 to the 0 power? 1. What's 1 times 200? So the answer has to be D. Just reconfirming it with extra information. Now question number 16, a medium level question. And still, it could be a drag if you're not familiar with this stuff. Now check out, each answer showing us our starting values. Right there, just knowing that, more than likely C is going to be between C and D in this question. More than likely because of the patterns of the answers that you've seen before. Now what's our factor? Our factors are right in there. Remember how ridiculous the previous factor of 200 was? Imagine 44,000, which represents 100% plus 39,900%. That's kind of ridiculous, but you never know. The test could do that. But what are the other factors on answer choices C and D? Much more reasonable. You got 0.5 or you got 2.0, which is 100% plus 100%. Again, that 2.0 is 100% plus 100%, which is 200%. In decimal form, that'd be 2.0. But not showing you the 2.0, it's just showing you 2. But it's still saying 2.0. Let's go into the question since we already know what's going on with those answers. The number of bacteria in a liquid medium doubles every day. If it doubles every day, what's our factor? Our factor would have to be 2. Oh, dear lordy, lordy. Check out what we got. Our answer is right there. The only answer is showing us a factor of 2 is not C. That's 1 over 2. Is not A. That's 44,000. Ridiculous. And B is 44,000. Ridiculous. So these guys are out. The best answer is D. But Mr. Alberto, are we 100% sure? Let's check it out. There are 44,000 bacteria in the liquid medium at the start of an observation. Yep, this is the start, 44,000. For show, for show. So D's got to be the answer. Can't be C because that's a factor of zero point 0.5 or 50%, which is not our business. Question number 25. Supposed to be hard, right? Because this is question number 25. Oh, let me clear some of this business up. Whoop, clean up. Clean up in aisle 10. Bang. All right, let's do this business. A model estimates that at the end of each year, from 2015, 2020, whenever they give you years, right? Just pay careful attention because they might mess with the, oh, I'm sorry. Let's go to the answer choices. This is showing us a starting beginning value of 72 and we got 180. But we also know this is question number 25. It is devioso. But what about our factors? Our factors are either going to be 1.5, 2.5, or 1.5, 2.5. Okay, let's get busy, yo. So 2015, 2020, it says the number of squirrels in a population was 150% more than the number of squirrels of the population at the end of the previous year. All right, 150% more. Train your ear for this. Here's where they're messing with you. What does that mean in our parenthesis? That means 100% and how much more? Plus 150% more. That's what they mean by the green underlined parts of the words. If we add those two percentages up, we get 250%. We put that in decimal form, that's 2. Whoops. Slow down here, saving 2.5 in decimal form. Take a look at your answers. Which two answers are giving you 2.5? It ain't A, it ain't C. So now it's got to be between B and D. Continue reading. The model estimates at the end of 2016. Oh, wait a minute. What did we start off at the beginning? At the end of each year from 2015 to 2020. But now they're saying at the end of 2016. So it's a year later. So they're telling you when T equals 1. They just described that at the end of 2015 because we started at 2015. So at the end of 2016, that's T equals 1. There were 180 squirrels in a population. So that means our formula, if you follow, right, if you follow along carefully, that means N is equal to our starting value. I don't know. Let's just call it X, right? But our parentheses is certainly going to be 2.5 to the T power. What is our T value? We said it's going to be 1, right, to the first power. And they said it's going to equal 180 squirrels. That's what they described in the red. At the end of 2016, that's when T equals 1. We already know it's an increase of 100% plus 150% is 2.5. We don't know what we started off with, the beginning value. So which of the following equations represents this model where N is the estimated number of squirrels in the population T years after the end of 2015? So this is slickly describing your beginning value, X. Okay, so which one has to be the answer? Now, answer choice D is showing us our starting value, but they're actually telling us the answer, N, is 180. That cannot be the answer. The answer has to be B. The starting value is 72. The factor is 2.5 to the first power, then that will equal 180. Now, if you plug that into your calculator, you're going to get that it equals 180 when T equals what? When T equals 1. Ooh, ooh, ooh. Done. That was a dirty question. Man, it's so good to know this one because it eliminates all the different styles of questions that they can throw at you. It's probably the toughest of the toughest, but I'm sure I've got some others up my sleeve from these guys and I can share it with you in the future. All right, the last one. The last one, we're definitely going to see at least one of these questions. And if you do see it, you're going to own it. But of course, they put it deep into the math section of the exam. So it's super hard for most students. For us, we're going to make this sucker super easy. Now, take a look at the answer choices. Same thing. This is going to be our starting value, and each one of them are different. We good? Then what's our factors? Our factors are in there. Those are your percentages. So each of them is showing that they're going up 60%. 100% of last year plus 60% of last year. So it's 100% plus 60%, which is 160%, which is 1.6 in decimal form. All right, we're good. Now the exponents. Each of the exponents are different. And we're good with that. No problem. We know we have to plug in X. Now let's go into the question and see what they're dealing with. For the exponential function f, the value of f of 1, so tell us when x equals 1, then we're going to get an answer of k. Our answer is going to be our y value. So x equals 1, y is going to equal k, where k is a number. Forget about the word constant, it's just a number. But in our case, it's the same as saying y. They just change it from y to k. Now, which of the following equivalent forms of the function f shows the value of k as a coefficient or the base? Here, let me underline that in yellow, because this is a yellow way of asking you a question to confuse you. Which of the following equivalent forms of the function f shows the value of y, right? I'm going to put y underneath, shows the value of y as the coefficient or the base. Okay, remember the arrow in blue, their starting value? That's also known as the coefficient. Each of these are known as the coefficients. So when we have f equals 1 or x equals 1, like they told us there, which of these formulas will give us the same answer as the coefficient or the starting value? Let's go straight right into the answer. The answer is C. Why? Because if I suck in 1 for x, what is 1 minus 1 equal to? It's going to equal a big fat 0. What is anything to the 0 power? 1. What is 1 times 128? 128. Does it equal the coefficient? Yes, and that's your answer. You guys test the other answer choice and see if you plugged in x equals 1, that you'll get the same answer for A, 50. You won't. You get same answer 80. Nope, you won't. Or you get the same answer 204.8. Nope, you won't. So therefore, bing, bing, bing. C is the best answer. Ladies and gentlemen, remember, I don't want you to be scared of this test. I need you to practice and get familiar, because if you practice and get familiar with this stuff, you are going to own this. Remember, I don't want you being like the young Justin Bieber, baby, baby, baby. I want you to be like this Justin Bieber, Coachella, owning the concert, whether it was lip sync or whatever, who cares? The guy's making bank. And then what happened to Drake? I haven't heard from him in a long time. If you have any questions, like, subscribe, share, subscribe, comment. Word of the day, text me at 786-877-7231, DA, if you need access to these documents. Peace out.